Okay, welcome back, YouTube. This is the next video in my series of videos about making a computer out of transistors. This one's pretty cool. Uh, I'm pretty sure I built two circuits. I'm pretty sure both of these circuits will be useful in my computer. Not 100% sure where yet, but I definitely wanted to build them, so stay tuned. They're pretty cool. Okay, the first circuit I built is a binary decoder. So I may use it. Actually, I built this much of the binary decoder, like that much of the binary decoder, which is only 4 bits. And I started drawing the rest of this because I want to make an 8-bit binary decoder. But then I think I need like 4 more rows of connections, and I already had this much, this built here. So maybe I'll build another one that's 8-bit at some point, because I think for my memory, it would be cool to have an 8-bit one, because then I can have, 8 bits of memory, but also I'm not totally sure how it works with the memory. I believe using the binary decoder along with my next circuit, which is a multiplexer, which is this half down here. Actually, they're both pretty similar. And then they connect together through here. Whenever I build the multiplexer, it uses the binary decoder, and then they, connect across like that. But I'm going to disconnect these 4 wires right here and just show you the binary decoder first. Okay, so here is the binary decoder. It's 4-bit binary decoder. I have these 2 switches here. And depending on what it does is, depending on what is selected here, determines which output is active. So right now it's 0, 0, so that's the first output is active. Now if I turn, the first 1 is 1, and then 2, 2, and 3 isn't working. Sometimes, there you go, breadboards. Give it a little jiggle and it works. Okay, so yeah, there you have it. So that's pretty cool, right? So that's a binary decoder. It's a 4-bit decoder. I would like to add one more input, which would give me how many more LEDs? 2 more LEDs? No, I need more than that, right? No, because I was thinking I could use it for my 7-segment display, right? It wasn't working quite right. So then I could use it to, actually, if I did 4, but I think I only need 3 for 7 segments. To get the number 7, right, was 3 bits. 4, 5, 6, 7. Yeah, I could get 7. So I just need one more switch, and it would be 3 more LEDs, I think. All right. 1, 2, 3, 4. It would be 4 more LEDs. Yeah, one more switch, that would give me 8 bits. It would give me 1 byte, which could be useful for if I build the kind of memory that I'm thinking, it would give me the ability to select rows and columns of memory. Anyhow, so that's the first part there. I'm just babbling. Let me quit babbling. That's the binary decoder. Pretty cool. So obviously, let's see it quit working again. Oh, power came off. Yeah, so depending on the switch that's selected, that's the output that is active. Okay, so let me stop here. I'll connect my jumpers back across here, which are all of these. I'll connect these jumpers back across, and then I'll check back. Okay, so here is the entire multiplexer wired up. You can see I got my outputs going to one of the AND gate inputs. Also, this took me a little bit to get working, but I had to, here's an AND gate and then an inverter. After each AND gate, I had to add an inverter. I'm not sure why. So like this doesn't show that, but there's another transistor right here after each one of these. And then also here too. after each one of these AND gates, there's another transistor, which I think is what really makes it an AND gate. Without it, it's really a NAND gate. And then the OR gate is just an OR gate because I can put the resistor and LED in series, which makes it an OR gate. Anyhow, so here's how it works. This is how a multiplexer works. The idea is that depending on which select number is selected, if I have 0 selected, then the 0 will be active, and that bit, the bit that is on 0 is what's going to be displayed at the output. When I select 1, then the 1 bit will be displayed, and that's what's going to be displayed on the output, and so on. So let's try it. Right now, you can see I have 0 selected, and which is the first bit, and it is turned on. So it is making it to the output. And you can see this by turning it off. See, it goes off. Here's another thing you can do. You can turn it on and turn this one off. See, none of the other ones affect. Look, I'll turn it off. I can turn any of the other ones on. No other bits affected because that I have bit 1 selected. So whatever is in bit 1 is what's displayed on the output. Now if I go to bit 2, the second bit, look, bit 1 no longer does anything. But bit 2, it displays what's on the second one. Okay, now if I go to bit 3, or really 2 in binary, the third one, see, 3, whatever's on 3 is displayed. And so I could do like this, and I go to, and I'll just show you, 4 is the same thing, the fourth bit, which is 3 in binary. Whatever's on 4. So we can show it like this. I have 1 stored as a 1, 2 as a 0, 3 as a 1, 4 as a 0. So if I go to 3, if I go to 2, it's showing the 1. If I go to 1, it's showing the 0. If I go to 0, it's showing the 1. So that's pretty cool, right? It's a multiplexer. That's what multiplexers do. Depending on which one you have selected, that's the input that will be displayed on the output. So I think this multiplexer and potentially the binary decoder by itself could be used in my computer circuitry. So anyhow, I saw these two circuits, and I'm like, oh, I want to build that next. So at least now I got that, and now we'll have to see where to go next. I'm going to look into the memory a little bit more to see if I want to do like a memory matrix, which then I think would use a circuit like this to select a memory location. But that could get just too deep for, you know, just this TTL bunch of transistors. You know, that could take like 10 breadboards with 500 transistors just to do. I don't know. We'll see where that goes. Otherwise, I'll probably work on just some small amounts of memory for the next video. We'll see where it goes. All right. Well, thanks for watching, and stay tuned for the next one. Have a good one.